Hey, welcome to Compounds with Molar Mass and Particles. This will be very similar to our previous one, just as an additional step, and that's molar mass. So we're calculating the molar mass of the compounds and calculating the number of particles in a given mass. So same ideas, just the molar mass is the new part. So we have the molar mass for compounds. We first need the correct chemical formula. Don't worry, we'll provide that for you. To list out how many of each element you have in the compound. So in the ammonium sulfate, you've got 2 nitrogen, 8 hydrogen, 1 sulfur, 4 oxygen. So total count up. Multiply how many you have of each element by its molar mass on the periodic table. So you've got 2 of the nitrogen, 14.01, 8 of the hydrogen at 1.01, 1 of the sulfur at 32.07, and 4 of the oxygen at 16. Use your calculator to add it all up, and that is the molar mass for the compound. Just that simple. All right, let's take a look at an example. So we have sodium nitrate here. So we have 2 of the NAs. We got 1 nitrogen. And we've got 3 oxygen. So you need to pick up on that. So we have 2 times the 22.99, and that's grams per mole. Need always units. We've got 1 of the 14.01 grams per mole. And then we have the 3 times the 16.00. Always go 2 decimal spots, grams per mole. So up top, we've got, you can write them out what you have equally, or if you just want to put them all together, give your 107.99 grams per mole of our sodium nitrate here. Now I'm just realizing that this is an incorrect chemical formula. I'm not sure why I even put it that way, but let's just roll with it, that if what you're provided should be correct, you're just going through this process to get there. So let's look at another example. Again, this one has a correct chemical formula. So if we have 2 aluminum and 3 oxygen. So the molar mass for aluminum, 26.98, that you find right on your periodic table. Again, we always are putting grams per mole. Likewise, we have our 3 times our 16. We would expect you to use a calculator to do all the multiplication and stuff. So this together being multiplied and added gets your 101.96 grams per mole of your aluminum oxide. So when you're asked this question on the test where it's just molar mass, you need to show this level of work. When you have a molar mass that is part of a conversion, you don't need to show any work at all. But we want to make sure that you can understand and know how to do it this way in full, so it helps us see any kind of errors and thoughts that you might have that were incorrect. Alright, so let's take a look at some of these other examples we can do here. We're actually going to put all the examples in the next video, help break it up, give you some time to think, and come back to it. So check out video 2 for the examples of proficiency. See you then.